Alright, this is day 26 of solving math problems until a whole life member notices me. Well, today isn't really much about solving a problem, but it's more or less about proving the law of sines today. So pretty much we're going to do a proof rather than solving a problem. It's kind of a nice change of pace, right? So, pretty much for any triangle, right? A, B, C, right? We have lengths A, B, and C. So pretty much lowercase a and b and c are pretty much lengths from capital A to B, but capital A is pretty much our angle, and capital B is our angle, and capital C is our angle. So pretty much what we want to do is prove the law of sines, right? So what we're going to do is how do we make use of our function, right? How do we make use of our friend sine? Well, the first thing we're going to do is pretty much form a right triangle by pretty much creating a bisector, right? Because we're bisecting our triangle in half. Here we're going to have is pretty much two right triangles now, which we could label this H. And we're going to have sine of A, or capital A, is equal to opposite or hypotenuse. So we have H over C. And for sine of C, that is equal to hypotenuse over, or no, opposite over hypotenuse again. So that is A. And pretty much here, right, we see that we have H in both equations, which we could relate our sine of A and sine of C to each other. So solving for H here, we have C sine of A is equal to H. And we can pretty much substitute this back into this H. So that will give us sine of capital C is equal to C sine of A over A. And divided by C, right, we're going to go ahead and get that sine of C over C is equal to sine A over A. So pretty much we found that we have that identity, right? So now we prove that we have sine of C over C is equal to sine of A over A. And we could have followed the same logic, right? Pretty much like this time now we're just going to make a bisector from a different angle, right? So what we're going to do, right, is now we're going to just pretty much bisect this triangle from angle C to lowercase c, and we're going to name this again H. And here we could go ahead and say sine of B is equal to opposite over adjacent, which is H over A, and sine of A is equal to H over B. And then doing the same progress, right? We're pretty much going to end up with sine of A over A is equal to sine of B over B. And pretty much we could say that that one is also equal to these two other expressions. So we have sine of B over B is equal to sine of C over C and sine of A over A. That was fairly a simple proof, right? And we could also just take the reciprocal of every single expression since that is possible. Because it really doesn't change the value of our function, right? It doesn't, like any function, like if we just flip it over, it's not really going to change anything. So yeah, pretty much for sine of c over c. We could write this again as a over sine of a is equal to b over sine of b. I just fix this. There we go. And c over sine of c. So yeah, pretty much like it doesn't matter which one we use, like they're both going to be the same. They're still going to pretty much show that our angles and lengths are connected in a way. So yeah, that's that for the proof of the law of sines. So yeah, woohoo! Law sines proved. So yeah, I know we have some unstraight lines, but yeah, thank you for watching and bye bye.